All right, so looking at the second page of this note set, we're going to get into some of the problems. A very common problem you'll see is when you have two triangles that are congruent like this, where they're just giving you the symbols. So first thing I always recommend is whenever you see a question like this where they say given triangle blank is congruent to triangle blank, draw yourself a picture. A lot of times if you draw two triangles, it really doesn't matter the shape as long as you're really careful on the labeling. So I've got PQM for that one, and then I'm going to draw a triangle that's pretty close to the same, as close as I can do by hand, but I'm going to be really careful to label it in the same order. So this one's HJL. All right, so it's PQM, HJL. I'm going in the same order around each. Now what that does is it lines up my corresponding spots so that I can grab congruences that I know for sure are true. So I'm going to take some of the information they gave me. They told me PQ was 15. All right, they told me M was 37. And they told me J was 58. Now, notice my picture is not to scale. I'm not going to let that throw me off at all when I deal with this. So first thing I'm going to do is that 15, the corresponding spot, is right over here. So we have HJ is 15. All right, then it starts asking about the angle. So I'm going to pull one piece over. That 58 would have to go on the top up here, so I have a 58 there. So I've got 37 and 58, so that's going to be 88 plus 7, or 95. So I've used 95 degrees, so I have 85 degrees left for that last angle. Now, using corresponding angles, I can carry these over to the other one. And again, notice I'm focusing on the diagram I drew more than the questions being asked, because if I do that, I'm just going to intuitively work my way through the problem. Then I'm going to go over to the questions on the right and say, okay, they want measure of angle L. That's 37. They want measure of angle Q. That's 58. And they want measure of angle H. That's 85. Whereas if I would have went over and immediately started to try and figure out angle L, it may not have naturally come out of the diagram as easily as it did when I just tried to fill in everything I know about the picture right out of the gates. So I really encourage, try and fill in the picture as much as you can, then look to what specific pieces of information they're asking for. It can occasionally cost you a little bit of time, but I've seen more issues with people getting roadblocked because they're looking for a certain piece of information that's almost impossible to get unless they did a few other things. Or if they would have just looked at the diagram blankly, they would have gotten through it no problem. So the next thing we're at here is we've got another theorem. So this is a third angle theorem. All right, so this one kind of makes sense. We know we have 180 degrees in a triangle. All right, so if we have 180 degrees, these three angles here, I'm going to call them 1, 2, and 3. All right, would have to add up to 180 degrees. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. Now in this next picture, I've got angles 4, 5, and 6. All right, so it's a triangle again. So measure of angle 4 plus measure of angle 5 plus measure of angle 6 has to equal 180 as well. All right, so next thing I'm going to look at is I'm going to look at, do I know of any congruence? And there's clearly some markers here, so we know angle 1, all right, is equal to angle, let's see, 4. And angle 2, all right, angle 2 is equal to angle 5. So I'm going to take this equation and I'm going to do some substitutions in it. All right, so I have angle 4 is 1, so I've got measure of angle 1 plus angle 5 is the same size as angle 2, so measure of angle 2 plus measure of angle 6 equals 180. All right, so I substituted those two equations into that to get this result. Now I'm going to pull these two together and use a little algebra 1. So the top line there, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. The bottom one we had there, after the substitutions, measure of angle 1 plus measure of angle 2 plus measure of angle 6 equals 180. And I'm going to eliminate, so I'm going to subtract those two. Those cancel. Those cancel. Measure of angle 3 minus measure of angle 6 equals 0 because those cancel, which means measure of angle 3 equals measure of angle 6. All right, so when we look at this, if I have two angles congruent and two triangles, I know that third angle has to be congruent as well. So the theorem itself is if two angles of one triangle are congruent to two angles of another triangle, then the third angle of each is also congruent. All right, and again, we kind of proved it right there as we went through, because 1 and 2 are the same as 4 and 5, so 3 and 6 would have to be the same as well. Now, taking a look at the next piece here, we've got one more theorem and a couple little things. So it says congruence of triangles is reflexive, symmetric, and transitive. All right, so when I look at this, this is not a huge stressor since we're taking a little less formal approach to proof. But reflexive basically means you're congruent to yourself. All right, so a triangle has the same shape and size as itself, which seems kind of nonsensical, but we're going to use that for some of our congruence proofs later on, this idea that maybe a segment that's involved in both triangles is a shared side, so we say it's congruent to itself. Now, symmetric basically means if two things are equal, they're equal in either order. So this says a triangle ABC is congruent to RST, so we're going to say triangle RST is congruent to ABC. All right, so whichever order they are congruent. Now, transitive is the one we'll use the most. It's a lot like law of syllogisms in our logic work we did. All right, we have ABC is congruent to RST, but we also know RST is congruent to MPQ, so we can take out that middle connector and just say triangle ABC is congruent to triangle MPQ. All right, and we have that congruence there. So those are our theorems. We'll talk about those more when we get to 4.4 and 4.5. But again, reflexive, everything's congruent to itself. Symmetric, if they're congruent, triangle 1 to triangle 2, then they're congruent triangle 2 back to triangle 1. And transitive, if you have 3 triangles, if the first 2 are congruent and the last 2 are congruent, then the first and the last are congruent. All right, moving on to page 3. These are some of our sample problems. So determine whether the triangles are congruent. All right, so we're going to have to lean on some past knowledge here. So first thing I noticed in this picture is we do have 3 sides that are marked as congruent here. And we also have parallel lines. So I'm going to start by leaning on alternate interior angles, which lets me say H and K are the same size. All right, it also lets me say that G and L are the same size. All right, now, if I can show these, I have the 6 points I need. All right, I have the 3 congruent sides and the 3 congruent angles. And those 2 happen to be vertical angles, so they are congruent. So we'll go ahead and mark that. All right. And I have the 6 congruences I need. And I can say that triangle and the triangle are congruent. Now, we've got to be really careful about labeling here. So when I mark the angles, I mark them in order 1, 2, and 3. So when I label, I kind of follow that same progression. So I have the 1 mark on the angle is H, the 2 is G, and the 3 is J. Right? And that's going to be congruent on the other one. If I go 1, 2, 3, that's K, then L, then J. All right, and that's our congruent statement. Now, the order is not particular in the sense that I could have labeled the first one as G, J, H, but if I did that, I'd have to change the second one accordingly, so that would be L, J, K. All right, so the 2, wherever you see the H, that has to be where the K is. Wherever you see the G, that's where the L is, and wherever you see the J, that's the J on the other one as well. All right, that keeps that correspondence between the parts so that we can just look at that labeling and know what things we can set equal to each other. All right, moving on to B, it says given AC is a median of triangle ABD. All right, so median is a word that we probably haven't seen yet, but basically it's going to go through and it's going to break the opposite side in half. All right, so median cuts the opposite side in half. So that piece of information actually gives me a congruence here where I can say BC and CD are congruent. All right, now here's our first opportunity to deal with the reflexive rule. All right, because notice AC is shared by both of those. So really what we'll say is we'll say AC is congruent to itself. All right, if we were doing full formal 2-column proofs, we'd say that they're congruent by reflexive, right, because they're equivalent to itself. Now, we have one more angle we need to make to get the 6 pieces of congruence we need right now. Later in future sections, we're going to try and cut down on what we need, but we need that third. So we're actually going to lean on a theorem from up above, which was the third angle theorem. All right, I've got the 35 and the 90 is congruent to the 35 and the 90 in the other triangle. So that means by that theorem, this last piece, they have to be congruent. Now, we could go brute force. We could actually find that value. We're going to have 180 minus 90, which is 90 minus 35, which takes me to a 55. And that would be the same on both. But we can also just lean on the theorem and say, hey, I know that third angle has to be the same size because of this theorem. All right, so from here, we can make a congruent statement. So we're going to say triangle BAC. All right, and again, I started here, went up, and then down this side. So I'm going to do the same thing on the other side. I'm going to start at D, triangle D. I'm going to go up to the 35-degree angle, so A, and then down, so to C. And that's our congruent statement for that picture. Now, if I go to the 2 examples here, this is just going to walk us through. Key thing with these is draw a picture, all right? So I will be back in the next video and give you a quick run through of these 2 if you need it. All right, thanks, bye.